The moment your car's AC stops blowing ice cold, you are walking into a $500 trap. Shops will hook up manifold gauges, shake their heads, and quote you for compressor replacements and Freon recharges. What they will not tell you is that the real test for your cooling system takes 30 seconds. No tools, no cost, and it proves whether you need a massive repair or just a 5-cent fix. They skip it because there is nothing to bill you for. I am saving that test for last. There are 12 tricks that explain why AC systems fail, what gets misdiagnosed, and what you can fix yourself for almost nothing. Each one builds on the last. By the time we reach trick number 1, you will understand your cooling system well enough to walk into any shop and know whether they are helping you or ripping you off. One more thing. Trick number 6 is going to change how you cool down a car that has been baking in the sun. Most people do it completely backwards. That comes later. We start at 12. Trick number 12 will surprise you because the part involved costs less than a fast food meal. There are 2 tiny sensors hidden in your climate control system that most owners have never heard of. When either one fails, your AC starts doing things that make zero sense. No warning lights, no strange noises, just weird behavior that does not match what you told the system to do. The first one is the ambient temperature sensor. It tells the computer what the outside temperature is. Simple enough. But when it feeds wrong numbers, the computer makes bad calls. It might baby the compressor because it thinks the outside air is 70 degrees when it is actually 95. It might flip between fresh air and recirculate on its own. It might push air to vents you never selected. Most people bring this complaint to a shop and spend hundreds chasing the wrong thing. The sensor sits near the front bumper or behind the grille. You can test it by checking resistance under known temperature conditions. But here's the mistake people make. They swap the sensor without checking the wiring harness first. Damaged wiring gives you the exact same phantom readings as a dead sensor. Replace the sensor with bad wiring and you just threw money away. The second sensor is worse. The evaporator temperature sensor. A small heat-sensing probe mounted near the evaporator coil behind the dash. Its job is to shut the compressor off before the coil freezes solid. When it fails or gets covered in grime, the compressor kicks on and off in rapid bursts. Cold for a few seconds, then warm, then cold again. You might hear clicking under the hood. That short cycling chews up the compressor clutch, kills efficiency, and makes it nearly impossible for a shop to get clean pressure readings because everything is bouncing around. To test it, compare the sensor reading against an independent temperature probe placed right next to it. If the sensor says one thing and the probe says something completely different, the sensor is lying. Sometimes cleaning it or repositioning it on the coil fixes the problem. If it still reads wrong after that, replace it. These sensors cost between $15 and $40. On most cars, you can get to them without tearing the dashboard apart. So, one of the cheapest parts in the entire system can mimic some of the most expensive failures. A $15 sensor pretending to be a dead compressor. That is like your smoke detector chirping and someone telling you to rebuild the kitchen. Trick number 11. If a cheap sensor can fool the whole system, wait until you see what happens when people wrap a specific pipe under the hood with foam. Some people swear by it. Others say it destroyed their compressor. Both sides have a point, and the difference comes down to one detail most people skip. Under your hood there is a pipe called the suction line. It carries cool refrigerant vapor back to the compressor. The engine bay around it is scorching hot, so that cool vapor absorbs heat as it travels. You can actually see this happening. The suction line sweats visibly when the AC runs because the pipe is cooler than the surrounding air. The idea is simple. Wrap the line in insulating foam. Less heat gain means cooler vapor reaching the compressor. People who have done it report faster cold air on startup and slightly cooler vent temps. But the foam type matters. Do not use cheap open cell foam from a hardware store. It falls apart under engine heat. You need closed cell foam, neoprene, or XPE, sealed with aluminum foil tape. Keep it away from exhaust components. Here is the rule you cannot break. Only insulate the suction line. Never the high-pressure liquid line. Never the accumulator. Insulating the wrong side traps moisture and messes with heat rejection the system needs. Take baseline vent temps and compressor cycling patterns before and after. Without data, you are just guessing. Now here is the warning most people skip. Some manufacturers leave that exact pipe bare on purpose. That is not a mistake. In certain cars, engineers designed it so the pipe absorbs some engine heat. Wrapping it ruins that balance. It cools the gas so much it turns back into a heavy liquid. Compressors cannot pump liquid. It shatters them from the inside. A completely wrecked compressor, just from wrapping a pipe in cheap foam. So, this is a reversible experiment for people willing to measure and monitor, not a universal upgrade. If anything sounds wrong after installation, pull the foam off. And insulation does not fix real problems. Dirty condensers, dead fans, low refrigerant, clogged filters, Fix the fundamentals first. Trick number 10. Here is how you read exactly what the system is telling you. 6 tests that tell you precisely what is failing. Most need nothing more than a thermometer and patience. And one of them, the pressure equalization test, is something even experienced mechanics forget to do. If you remember one thing from this video, make it this. No single reading tells the full story. You need multiple measurements read together. That is the difference between guessing and diagnosing. Before testing, get the conditions right. Engine at roughly 1800 RPM, blower on max. Recirculate on. Doors closed. Testing at idle with poor airflow gives you inflated pressures that send you chasing the wrong problem. First, stick a thermocouple deep into the center vent, not an infrared gun. Infrared gives unreliable readings on vent surfaces. A healthy system should blow roughly 40 to 45 degrees below ambient. 95 outside should give you 50 to 55 from the vent. Temps stuck in the 60s or 70s means something is wrong, but not what. Second, run the AC hard for 10 minutes and look under the car near the passenger side. You should see water dripping. That is, condensate the evaporator pulled from cabin air. Steady drip means the evaporator is cold enough. No drip means either a clogged drain or a system that is not cooling at all. Third, pressure readings. With manifold gauges, watch the split. Low side should drop to around 30 to 40 psi on most R134A systems. High side should climb to 125 to 250, depending on outside temp. If nothing changes when the compressor kicks on, something is blocking it. Fuse, relay, seized compressor, or a restriction. Fourth, read both gauges as a pair. This is where most people get lost. If one drops while the other spikes, something is blocked inside. Both reading low means the system is short on charge. Both reading high means it is overfilled or the condenser is choked. Fifth, and honestly, this one drives me crazy because nobody does it, and it is the easiest test on this list. Turn the compressor off and watch the two needles slowly come together. How fast they meet tells you whether the valve inside is flowing freely or stuck shut. No extra tools. The gauges are already on. Just patience. Sixth, the RPM test. Rev the engine and watch. High side should rise, low side should drop. If pressures barely move, the compressor is your problem, not the metering or airflow. At this point, you know more about AC diagnosis than most quick lube techs. But trick number 9 is where real diagnosis separates from guessing. The single most violated rule in AC service, charge level. Here's a fact almost every car owner gets wrong. Refrigerant is measured by weight, not pressure. The manufacturer specifies an exact amount in grams or ounces. Pressure shifts with temperature, system design, and conditions. A system reading 35 psi on the low side could be perfectly charged, undercharged, or overcharged depending on the exact moment you check it. This is why those consumer recharge cans are a problem. Honestly, those cans should come with a warning label the size of the can itself. They force you to guess by pressure instead of measure by weight. A lot of those cans also have sealants that clog metering devices. Brand new problems from a $15 can. The correct procedure is recover, evacuate, charge by weight. That takes certified equipment. DIY work should stay outside the sealed system. Cabin filters, condenser cleaning, fan checks, drain clearing. Leave the charge work to a shop with the right tools. One more detail. Anytime the sealed system is opened, the receiver dryer must be replaced. It has a moisture-absorbing material inside that wears out. Once it stops working, moisture gets in and creates acid that eats away at the internals. When compressors fail catastrophically, metal debris contaminates the entire circuit. But all of that assumes you actually found where the refrigerant went. Most people skip that step entirely and just refill it. Trick number 8 is exactly why that is a mistake. It does not wear out. It does not get consumed. It does not evaporate away. If the system is losing refrigerant, it is leaking. Period. If a shop tells you it just needs a top-up every year, that is not maintenance. That is a bandage on a leak that is getting worse. Refrigerant carries oil. When it escapes, it leaves oily residue behind. Check hose connections, service ports, and the compressor shaft seal for wet, oily deposits. If visual inspection comes up empty, a soap bubble test with dry nitrogen at about 100 psi shows you exactly where gas is escaping. Electronic detectors help near the evaporator drain where you cannot see. And here's a clue most people miss entirely. Check the condensate water from the evaporator drain. If it looks oily, that can point to an internal evaporator leak. Once you find it, the repair sequence matters. Fix the leak. Replace the dryer. Evacuate to deep vacuum. Charge by weight. Verify. Trick number 7. Here is a scenario that burns more money than almost anything else in AC repair. You turn the AC on. The blower runs. Air comes out, but it is not cold. Not even slightly. Most people assume bad compressor, $800, maybe more. But in many cases, the compressor is perfectly fine. It is just not turning on, and the reason might cost 5 cents to fix. Pop the hood with AC on and watch the front of the compressor. Look for the clutch plate to pull in. Listen for the click. No engagement means zero refrigeration. Check fuses and relays. If identical relays exist elsewhere in the fuse box, swap them. Dead relay fix costs under $15. Measure voltage at the clutch connector. No voltage means the problem is electrical. Trace it upstream before touching anything expensive. The decisive test. Disconnect the clutch connector and send battery power directly to it with a fuse jumper wire. If the clutch grabs with direct power but will not engage under normal operation, the compressor itself is fine. The problem is somewhere in the electrical chain feeding it. Relays, wiring, or a safety switch. If the clutch engages but slips, check the air gap with a thin measuring gauge. Many compressors need a gap around the thickness of 3 business cards. Remove a spacer if needed and tighten the center bolt to the manufacturer's spec. That 4-step chain is how you avoid spending $800 on a compressor that was never broken. If that just saved you from a compressor replacement you did not need, do me a favor and hit that like button so YouTube shows this to the next person sitting in a shop lobby about to make the same expensive mistake. Now, trick number 6. The one I told you would change how you cool a hot car. It is almost too simple. Even a perfectly working AC fights an uphill battle if the car sat in direct sun for 2 hours. A parked car works like a greenhouse. Sun passes through the glass and gets absorbed by the dashboard, seats, steering wheel, and headliner. Those surfaces store heat and radiate it back. Interior temps can pass 140 degrees. But here is what surprises people. The air temp is only half the battle. Stored thermal energy keeps pouring out of every surface even after you start the vents. That is why cranking the AC in a sun-soaked car feels useless at first. Prevention is the biggest win. A reflective windshield sunshade drops cabin temps by 20 to 30 degrees. Ceramic window tint blocks infrared radiation. Parking in shade is free and makes the biggest difference of all. For electric vehicle owners, precondition the cabin while plugged in. Grid electricity is cheaper than battery range. Now, the actual cooling sequence most people get backwards. You get into a scorching car, slam the doors, crank everything to max, hit recirculate, then sit there sweating. Here is why that fails. A cabin at 140 degrees means the AC is trying to cool impossibly hot air, loop it back, cool it again, loop it again. Each cycle barely dents the temperature. Instead, do a hot air purge first. Open the windows. Some people use a door pump technique, where you open one window and rapidly swing the opposite door to push the hot air out. Others just open everything for 30 seconds. The goal is replacing 140-degree air with outside air at 95. That is a 45-degree head start before the AC even touches it. Then close everything and switch to recirculate. Now, the system is recycling air that started at 90 instead of 140. Each pass through the evaporator takes a bigger bite. Comfortable temperature in a fraction of the time. One warning though, do not leave recirculate on for more than 20 minutes at a stretch. Recycled air builds up CO2 from your breathing, and it will make you drowsy behind the wheel. Switch to fresh air periodically on longer drives. Now, coming to trick number 5. Everything so far assumes the AC cools the whole cabin evenly, but what happens when one side blows ice cold and the other feels like you left the heater on? That complaint drives people crazy because nothing seems logically wrong. Blower works, compressor runs, refrigerant is fine, driver side is 40 degrees colder than passenger. The AC system itself is almost never the problem. The real failure is a small motor behind the dashboard called a blend door actuator. Its job is to mix cold evaporator air with hot heater core air to hit whatever temperature you selected. When the motor seizes or strips its internal gears, the door gets stuck and lets hot air leak into the cold air stream on one side. This shows up across Honda, Subaru, Toyota, Mercedes, Ford, Kia, Volvo, and dozens of other makes. The first clue is usually sound. Clicking, grinding, or buzzing from behind the dash during temperature changes. That usually means stripped gears. You can often reach the actuator through the glove box opening and see whether the linkage is moving or stuck. The fix is replacing the actuator with an exact part number match. Shaft geometry and electronic feedback differ between part numbers, so a substitute from a different model can cause new problems. After replacement, many systems need a relearn procedure. The actuator costs $30 to $60. One of the cheapest fixes for what feels like a catastrophic failure. One Honda Civic owner on a forum said he spent $400 at a dealer for what turned out to be a $40 motor. He replaced himself in 20 minutes. Check model-specific forums before ordering parts. The community has detailed guides with correct part numbers. Trick number 4. You can have perfect charge, a healthy compressor, working blend doors, and good fans, and the AC can still smell terrible and blow weak air. The reason is hiding behind your dash, and most people have never cleaned it once. The evaporator coil sits cold and wet in a sealed dark housing, perfect for mold. Over time, a slimy layer of bacteria and fungus coats the fins, blocks cooling, and creates that musty, stale smell that hits you when you first start the AC. Not just gross, a real concern for anyone with breathing issues. Foam cleaning is the first step. No rinse evaporator. Foam sprayed through the cabin filter slot dissolves the buildup and drains out through the condensate line. After that, make sure the drain flows freely. Clogged drains trap standing water and accelerate the mold problem. Some vehicles are notorious. BMW E39 and E53 models with ribbed internal drain hoses resist simple clearing. Certain Toyota models have foam gaskets that deteriorate and divert condensate. The cowl area at the base of the windshield collects leaves and debris that decompose and get pulled into the ventilation. It takes 2 minutes to clear. The vinegar trick is worth knowing. A 50-50 vinegar and water solution misted through the fresh air intake while the blower runs on low distributes a mild acid across the evaporator. Kills mold cheaply between deep cleans. And here is the simplest habit most people never think about. Run the blower on fan only for 2 to 3 minutes before shutting the car off. No AC, just the fan. That dries the evaporator before the car sits. A dry evaporator does not grow mold. A wet one left in a warm car overnight turns into an incubator. This single habit prevents musty smells and costs absolutely nothing. Trick number 3. The AC starts perfectly cold. 10 minutes later, it gradually warms up. Compressor's still running. Everything sounds normal. But the cold air is just gone. The most common cause is evaporator icing. When metering problems, low charge or airflow restriction cause parts of the coil to drop below freezing, frost builds up on the surface. That frost insulates the coil from cabin air. Less heat transfer means warmer air from the vents. From the driver's seat, it feels like the AC quietly gave up, but it is still running. The evaporator is just buried under ice. The diagnostic test is dead simple. Turn off the compressor but leave the blower running. If the evaporator is iced, the warm cabin air melts the frost. After a few minutes, turn the compressor back on. If cold comes back and then gradually fades again as frost rebuilds, you just confirmed icing. The question becomes why, and the answer usually leads to the expansion valve, a small device that controls how much refrigerant flows into the evaporator. When it sticks open, too much floods in, and the outlet drops below freezing. When it sticks closed, too little gets through, and one section freezes while the rest stays warm. There's a small temperature sensing bulb attached to the pipe at the evaporator outlet. If it shifts out of position or loses contact, it feeds wrong readings to the valve. Repositioning that bulb is free and fixes a surprising number of these complaints. Low refrigerant causes the same symptom. With less gas in the system, the cooling effect bunches up in a smaller area and freezes it solid while the rest of the coil gets nothing. It looks like a valve problem but responds to a proper charge by weight. And do not rule out the cabin air filter. That one part connects to almost every AC complaint on this list, and the next trick explains exactly why. Trick number 2 is embarrassingly simple. 2 minutes, about $10, and it is probably the most neglected maintenance item in the entire car. The cabin filter sits between the outside air intake and the evaporator. It catches dust, pollen, leaves, and bugs. Many car owners do not even know it exists. It is separate from the engine air filter. When it clogs, everything cascades. A clogged filter starves the evaporator of airflow. The AC feels weak even though the refrigerant circuit is fine. But it gets worse. Reduced airflow can push the evaporator below freezing, creating the icing cycle we just talked about. Ice insulates the coil. Coil gets colder. More ice builds. A self-feeding problem that started with a dirty filter. On top of that, a saturated filter traps moisture and organic material, which feeds mold and causes foggy windows. Replace it every 6 to 12 months, more often in dusty or pollen-heavy areas. On most cars, it is behind the glove box and takes under 2 minutes with no tools. Costs $8 to $15. Quick diagnostic tip. If you suspect weak cooling from airflow starvation, temporarily remove the filter and run the system. If airflow immediately gets stronger and colder, the filter was the bottleneck. Replace it after testing. Never run permanently without one, because debris will coat the evaporator directly, which is far more expensive to fix. And now trick number 1. This is what I have been building toward for the entire video. The most common cause of AC failure at idle. The cheapest to diagnose. And the fix that most shops will never volunteer, because there is nothing to charge you for. The complaint is everywhere. Every automotive forum, every car group. The AC blows cold on the highway but goes warm the second you stop. Works fine at 60 miles per hour. Dies in a drive-through. You sit in traffic and the vents get warmer and warmer until the system might as well be off. Here is what is happening. The condenser sits at the very front of the car, in front of the radiator, right behind the grill. Its job is to dump heat from the refrigerant into outside air. At highway speed, ram air forces through it at high volume. Works great. At idle, there is zero ram air. The only airflow comes from the electric cooling fan behind the condenser. If that fan is not spinning, or if the condenser fins are clogged with bugs, leaves, road grime, or bent from a minor bump, it cannot reject heat. High side pressure climbs, cooling collapses. The system might even shut the compressor off entirely on a high-pressure safety cutoff. This is the test I have been building toward. The box fan test. A household box fan, aimed at the front of your car while the engine idles and the AC runs. That is it. If cabin cooling improves immediately, the problem is condenser airflow. Let me say that again. A box fan you already own tells you more about your AC than a $500 diagnostic. This one test separates condenser airflow problems from refrigerant issues, metering device faults, and compressor failures. If auxiliary airflow restores cooling, the sealed system is probably healthy. The fault is just the air moving across the condenser at low speed. That is the free trick most shops will never volunteer. After a positive box fan result, check whether the condenser fan actually spins when AC is on. Hood open, AC commanded on, watch and listen. If it does not spin, start with the fuse. A blown fuse is a 5-cent fix. If the fuse is good, swap the relay with an identical one from another circuit. Dead relay costs under $15. If fuse and relay check out, measure voltage at the fan motor connector. Voltage present but no spin means the motor is dead. No voltage means tracing wiring upstream. If the fan works but cooling is still weak at idle, clean the condenser fins. Rinse with a garden hose straight on to avoid bending fins. Apply coil cleaner. Brush gently. Work from the engine side toward the front so you do not push debris deeper. Straighten bent fins with a fin comb that matches the pitch. Be careful with the thin flat tube condensers on newer cars. They puncture easily if you press too hard. On vehicles with belt-driven mechanical fans, a slipping fan clutch produces the exact same symptom. The fan looks like it is spinning but does not move enough air. Fan clutch replacement resolves idle cooling complaints without touching the refrigerant system. That is 12 tricks. From a $15 sensor pretending to be a dead compressor, to a box fan that outperforms a $500 shop visit. Every single one exists on a spectrum from free to cheap. The expensive repairs are real, but they should be the last resort, not the first guess. If this video saved you from even one unnecessary repair, drop a comment and tell me what you found. I read every single one. And if you want one simple trick that makes your AC blow 15 degrees colder for under $20, I made a whole video on exactly that. It is right here on screen. I will see you in that one.